Hello dear students, I am Samir Velankar. In this video we will see quicksort algorithm. In the previous video we saw how to partition the array using partition function, and now the quicksort, which is a recursive function, is going to call the partition function repeatedly, or rather recursively, because quicksort is a recursive function. Now, the best way, which I like always, explaining a recursive function to anyone is that assume that I have to explain this quicksort recursive function. Then what I do is I start with the minimum data. For instance, let's say I have got an array which stores 100 and only 100. This is the array I have. Strange, isn't it? But I have an array in which there is only one element stored, which is allowed. Obviously, we can have an array A of only one element, which is 0 to 0. And the funny part is we want to sort this array in increasing order. Notice that this array is already sorted because it contains only one value. But still, we want to use quicksort to sort the array in increasing order. So the quicksort function is called by passing the array. The array now holds only 100, which is 0 to 0. Next is left. Left is 0 obviously, and right is also 0 because the indexes of the array run from 0 to 0. Now watch, there is nothing to sort in the array. Then inside the algorithm quicksort, there is a if statement written if left is less than right, but left is 0 and right is also 0. That means we are having the two indexes, left and right, which are equal. Now, when is the partition possible? You just ask yourselves, when is this partition possible? Partition is possible if there are at least two elements in the array, isn't it? That means left has to be less than right. If left is less than right, only then you can call upon the partition function. But if left less than right, as you see, 0 less than 0 is false, then there is no question of calling partition. And if you don't call partition, then there is no question of sorting the left part and there is no question of sorting the right part. That means nothing in the if is going to execute and the function is going to end empty handed. The function ends without doing anything because the array in the question was already sorted. Trust me, I got this particular explanation from one of the students in one of the vivas, and I was thoroughly impressed by that student who said that, sir, you asked me to explain the quicksort function, and I think I have explained it using one element. And he says that if there is only one element in the array, recursion won't be done. So the first thing you have to understand is that when will recursion stop, or when will the recursion here won't be done. Recursion won't be done if left less than right is false. If this condition is false, then the recursion won't be done and the function will simply end. Great, isn't it? Now, what if we had four elements in the array? Let's take a very small array. Let's say we have four elements. Let's say 100, 50, 200, and 70. Elements ranging from 0 to 3. So the first call to quicksort is going to be QS. I am writing in short QS. A, the array is passed, and the left passed over here will be 0. And the right passed, I'm sorry, I put the close bracket here, and the right passed, right counter passed to the quicksort is going to be 3, isn't it? 3. So when the quicksort function starts here with left equal to 0 and right equal to 3, what we are going to do is we are going to declare one local variable p over here, which will be very helpful later on. So the function is running and here is the p declared whose value is unknown yet. By the way, the if statement, which I am right now marking, is true because left is less than right, 0 is less than 3. Hence the if executes and we call the partition function. Now we are not going through the entire partition function again. You know that 100 is going to be our pivot, 100 is the pivot, and 100 will be fixed at proper place using the two counters I and j. Isn't it? We have seen it enough. So what I will do is I will directly show the result of the partition here, isn't it? If we do some rough work here, I and j start from the two extremes, and first time I is going to stop at 2 because that's the value greater than 100, and j is going to stop at 1 because that's the value less than, or oh, I'm so sorry, j is going to immediately stop. J is going to stop at third place itself because that's the value which is less than or equal to 100. Now I has not crossed j, so we are going to swap 70 and 200. I hope you are following me. This is just the partition process going on. What next? I will increase and stop at third place, and j will decrease and stop at second place. I'm not going through the entire explanation again, but now you see that j and I has crossed. That means 100 should be placed at second place of the array. J gives you the place of partition. So just cleaning up, 100 will be at the second place and 200 will be at the 0th place, isn't it? Sorry, 70. So 100 will be at the second place and 70 at the 0th place. Now you watch, this 100 is fixed at jth place. And this position 2 will be returned by the partition function. Recall that partition function at the end. At the end, partition function always returns j. That j will be returned in the variable p. P is the place of partition. Hence, when the partition function ends, p computed over here is 2. Value of p is 2. That means second place is the position where the pivot was fixed. And now we have two partitions, left and right, which should be dealt with. So you watch the next line after the call to partition. Here we go. The next line after the call to partition is quicksort. Quicksort is called by passing the array, but this time the two counters passed are left, which is 0, and right now it becomes p minus 1. Now p minus 1 very well is 1 because p is 2. So hence, what are we passing really? What are the bounds that we are passing now? The quicksort is 0 and 1. That means 70 and 50 are the values which will be dealt with now. Isn't it so? And what's the next call here? Next call which I am marking. After we have covered this up, now quicksort will be called with a comma p plus 1. Now observe p plus 1 is 2 plus 1, which is 3. 3 to right. Check this, right is nothing but 3. So we are dealing 3 to 3 here in the right partition. Isn't it so? So there are three lines coming back to the quicksort. Whenever you are doing quicksort, there are three things you should do. Please wait a minute. I'll just switch on the marker. There are only three things you should do. First thing is partition the array. Partition the array A from left to right. But take the place of partition in P. Now, if P is the place of partition, then everything to the left of P and everything to the right of P is still to be sorted, isn't it? We have to sort the left part and we have to sort the right part. But what is the extent of the left part? Now, don't say that extent of the left part is 0 to P minus 1. Don't say that, because it won't be compulsorily from 0 to p minus 1. You recall that we have labeled this left end as left. So the left part will be from left to p minus 1. So we recursively call quicksort for the array A from left to p minus 1. And what about the right part? What is the extent of this right part? The extent of right part is p plus 1. And don't say this end is n minus 1. It's not compulsorily n minus 1, but we have labeled this right end as right. So we are calling quicksort recursively with the array A, p plus 1, comma right. That's it. These are the three things that we have to do in quicksort. But hello, when are these three things possible? These are possible only if left is less than right. Please try to understand this condition. I'm writing the condition on top here. Left should be less than right. Come on. if we have only one element in the partition, only one element, then left is equal to right. Now, if we say somebody, if we give this array to somebody and say, you partition this array, hello, the person will say that there is only one element, left is 0, and right is also 0. So to partition the array, there have to be at least two elements. I hope you are understanding. That means left is 0 and right is 1. Okay, left is less than right. Then only we will partition. Then only we will call quicksort recursively for left part, and we will call quicksort recursively for right part. And that's how the quicksort function works. Very interesting, isn't it? So, by the way, if we want to show the recursive tree, it's going to take more time. Basically, the showing the entire process of quicksort on paper itself is time consuming. I suggest all of you that you take some 4 or 5 element array and you actually run this quicksort function recursively by drawing a tree diagram. For example, you can start with an array something like 100, 50, 270. You first partition it. After partitioning, you will get two parts, left and right. Now for the left part, you run quicksort again, and for the right part, you run quicksort again. You may get two parts again over here, and for each of the parts, you run quicksort again. In fact, I have done that while I was learning quicksort. But in summary, you can remember that quicksort runs with these three lines: partition the array, then sort the left part, and sort the right part. These all things are only possible if left is less than right. I hope you have understood quicksort and partition function very well. Thank you very much.